Hello everyone. In last class we were discussing about lathe accessories and attachments, and in today's class we will discuss about what is catch plate or driving plate. Catch plates are used to drive the workpieces through docks when it is held between two centers. There are different types of catch plates are used. We will discuss one by one. First of all, we will see what is catch plates. As here discussed, catch plates are used for driving the workpieces through docks when it is held between two centers. When you held very heavy workpieces between two centers, as already you know, lathe machine has two centers. One is headstock center where the workpiece is held. This is workpiece, and on the lathe bed here tailstock. Here as you got dead center, in between that workpiece is held, right? So to drive very heavy workpieces we need good support, otherwise job will be in the vibration and there is a chances of spoiling the machine surface. So that's why to protect the workpiece from damage or to give good grip we need catch plates to drive the workpieces between the two centers. What are the two difference different types of catch plates we will discuss in the next. We have got here single pin catch plate. Here you can see the pin used is single, that's why it's called single plate clutch plate, single pin catch plate, sorry. Double pin catch plates, here the pins are two. Then it is double slotted catch plates. Double slotted catch plate means here with the help of bolt and nut arrangement. What happens here in this slot, it will be locked to the dog, and this catch plate is used to drive the workpiece. So to show this, what I wanted to do is I will show you a small video on the in the YouTube so that you will understand clearly. The animated video you will be understanding very easily. These are the catch plates.
नमस्कार मित्रांनो, कसे आहात? वर्क ड्राईव्ह करण्यासाठी म्हणजे फिरवण्यासाठी आपल्याला उपयोगात येतात कॅच प्लेट किंवा ड्राईव्ह.
I am looking for the animated videos.
Lenscart.com presents Airflex. Specs that flex.
You can see the lathe attachments
welcome
here.
to my little machine shop. I have toolbox, I have drill press, just a little Harbor Freight drill. I'm going to try and do all of this one-handed, so forgive me if it gets a lot shaky and stuff. But I'm going to loosen up my tailstock here and pull it back. I'll loosen it more. And out pops, hello, out pops the part. I have a center in.
This is the one example of what is that, in the carrier it will come. Okay, with the help of here you got screw, and here the workpiece is held and is rotated between the centers. This is a simple example how that also catch plates also will be used.
That end, and in the tailstock end, I have a live center,
This is called live center.
a number 3 Morse taper center locked into the spindle of my lathe,
This is live center.
and it's a live
One
center
center
because
at
it
the
rotates.
top.
And This is my dog driver plate. Some people call it a face plate. It's really not. It's a driver plate. Down there is my face plate. That's made of steel with lots of tapped holes in it. This is just a dog driver.
This is the catch plate. So you have got one slot, two, three, four slots are there for holding this carrier. It is used. Just see how it will be held here.
Plate, and this is a driver dog, which locks onto the part with a set screw. Yes, I painted it green to match my machine, haha. But basically this tang here gets driven because it's engaged into one of the slots, and then the live center goes into that. And I can't do this one-handed, but I'm going to bring the tailstock back up and mount the part in there, so just hang on a second. Oh, there's plenty of tension now. This is a live center where you have a driver dog like that. Most of the time we're just using a chuck in the spindle of the lathe, and then we support our part. If it's longer than 3 diameters,
When job need to be held between the two centers, we required here big catch plates, and this is the what your carrier.
sticking out, then you have to have the support of a center, of a tailstock and center. By the way, there's my steady rest, which I built, and I'm not using it at the moment, so it's locked down back here out of the way. Of a center, of a tailstock and center. By the way, there's my
This I will come to next part. It is called
steady rest, which I built.
Steady rest for very long workpieces. So steady rest is used. It consists of one screw over here and another screw over here, and in between this job, very heavy length job, very lengthy job will be held here. Okay, one side it will be supported at the other. Okay, center, right? So this is called.
And I'm not using it at the moment, so it's locked down back here out of the way. So anyway, I'm going to go ahead and dial in a cut on my machine.
Now we will discuss about resters. What are the different types of resters? So what is rest? Rest is taking the rest. Here rest is a device, mechanical device, which supports a longer workpiece to be turned between the centers or by a clutch at some intermediate point for preventing the bending during machining due to cutting forces and by its own weight. There are two types of resters commonly used. One is steady rest and second one is this follower or traveling rest. Here you can see in the very lengthy job needs to be machined. Sorry, very lengthy job needs to be machined. You will head within one center. Right? And what happens because of its heavy weight, this job will get vibrated, and what happens, there is a chances of bending in the length of the job, right? So that's why to give proper grip at the end, these resters are used at the other end. The stock is not used at that time. The stock is removed from the this one, or the stock is taken away, and at the middle this steady rest is used. We will discuss how it is used. Steady rest or center rest. Here you can see the diagram of the steady rest. So it provides a long slender workpiece to be supported, and it consists of cast iron base slides over the lathe bedway, and it can be clamped at the desired position wherever you want on the lathe bed. The upper portion of the rest is hinged at one end, to facilitate a setting. Here you can see the slide way means these are the lathe bedways. Okay, lathe consists of bedways, right? Here on bedway, here on bedway. On this steady rest can be setted and it can be moved on this wherever whichever position you want it on the lathe. Here you can see the diagram of steady rest. Here the two set screws arrangement will be there for upper portion of the rest for holding, and this is a screw, three screws for holding the job with jaw arrangement will be provided. All three jaws will be set for holding the very long job. This is a job, what you call it, work or job. This is called steady rest. Steady rest can be held at any position on the lathe bed. Next comes follower rest. What is follower rest? The follower rest has C type of arrangement, and here one side is totally open. Follower rest has C custom arrangement, double jaw. Here you have got only two jaws, whereas in the steady rest you have three jaws. Here you can see the example of machining tool and tool post is brought, whereas the workpiece is held here in the set screw jaws, two jaws. The main advantage of this follower rest is in the steady rest machining will happen apart from this entire steady rest. For example, this steady rest is there now. This length thickness, whatever the steady rest thickness, you cannot machine on the workpiece length. But whereas in the follower rest, along the entire length of the workpiece, machining can be done easily because it is open at the one end. So this is the advantage of the follower rest. Throughout the length, job can be machined. Throughout the job can be turned. But whereas in the steady rest, in the above case, what happens? Till here, steady rest is held, right? Steady rest is held here, and up to only this much length, it can be turned. 1 second it needs to be reversely, it is needs to be turned in the steady rest activity, and it is in the follower. The entire length you can machine. What is the difference between the steady rest and follower rest? You will see here. Steady rest function is to provide support to a long slender work. Very lengthy jobs can be following type of rest. This is steady rest, you remember, and this is the follower rest. And follower rest function is to support the workpiece to prevent the job from spring away when cut is made by the tool. That is the main true. Steady rest, it supports the workpiece at its pre-end, and the follower rest, it supports the workpiece just opposite side of the tool. In the steady rest, the workpiece is supported at the pre-end, and because it is supported at the middle, machining will make it half. And follower rest is supported just opposite side of the. What happens in the steady rest? The job is held like this. It consists of like this three jaws, one from here and another one from here. So This arrangement will be there. This is steady rest supported at the other end, only at the free end, and job can be machined up to this point. Whereas follower rest, if you take it, it consists of C type of arrangement, right? C type of arrangement means entire length can be machined easily. Here jaw will be supported at one end. Okay, so this is the advantage of steady rest. What I'll do is I will try to send some videos with steady rest follower so that you'll understand clearly. It is mounted on the bed of the lathe, which one steady rest, and follow rest is mounted on the carriage. The steady rest stays in one place. Steady rest stays in one place. The follow rest moves with the tool post wherever you want to get more grip. Each consists of 3 adjustable jaws, and whereas the follow rest consists of 2 adjustable jaws. Like this, these are the differences that are given here. The main simple differences you can remember here is in steady rest it consists of 3 jaws, whereas in the follow rest it consists of 2 jaws, and steady rest is supported at the free end, and the follow rest is supported at the just opposite side of the cutting tool, and steady rest is mounted on the lathe bed and follow rest is mounted on the carriage. Steady rest stays in one place and follow rest moves with the tool post. Like this, you remember the simple differences. This will be very important question asked question. Write the difference between the steady rest and follower rest. Make it perfect. What are the very important methods of work holding in a lathe? There are 4 important methods: holding the work between the centers, holding the work on the mandrel, holding the work in the chuck, holding the work on a face plate, live centers in a chuck, one end in a chuck and other end in a dead center. Like that, these are the methods, different methods used for holding the workpiece. This already we have been discussed now one by one. Lathe operations. The next part of this lathe machine is what are the different lathe operations we will perform: straight turning, shoulder turning, chamfering, thread cutting, knurling, pacing, polishing, pilling, taper turning, eccentric turning, spinning, grooving, spring winding, forming, drilling, reaming, boring, tapered boring, counter boring, tapping, internal thread cutting, undercutting, parting off, grinding, milling. See, around 25 operations, even more operations can be performed, which will be developed by the own machinist by his own experience itself. We will discuss here one by one. Turning operation. What is turning operation? This is a very simple concept. Turning operation in a lathe removes excess metal from the workpiece to produce a cylindrical surface or cone shaped surface to desired length by holding the jaw between the two centers. One is at a chuck and another at the supporting it by using the dead center, by using the tailstock. The tool moves longitudinally to give feed towards the headstock with the proper depth of cut. Here there are 2 kinds of cuts will come. One is called rough cut and another is called finish turning. Here you can see workpiece is held between the lathe to jaw chuck it is held, and other end it is supported or sometimes it is not supported in the tailstock. Okay, here hole is made, counter sinking hole is made, and this is the tool. What happens is job starts rotating and this turning tool is cut against across the length of the workpiece. This along the entire length of this job. Along the entire length of the job, turning is done. What is rough cut? The rough cut, initially what happens, the heavy amount of material needs to be removed So that time we need to remove the material by using the rough cut. So feed rate is from 0.3 to 1.5 mm per revolution of the work here. So it is for casted jobs where very more this one is given, allowance is given. Finish turning is used for after the rough finishing. So finishing turning nowadays is done in the CNC machines to get micro and very high accuracy and finishing. Finish turning is it is a case of high speed cutting speed, small speed, and very small depth of cut is given to produce a smooth surface. Here the depth of cut ranges from 0.5 to 1 mm, whereas you see in the rough turning it is 2 to 5 mm. See the difference. There in the rough turning it is 2 to 5 mm, whereas in the finish turning it is 0.5 to 1 mm. And field is from 0.1 to 0.3 mm per revolution of the workpiece. The cross feed micrometer dial is used to set an accurate depth of cut. Next comes what is shoulder turning. Shoulder turning is the operation carried out over a workpiece to produce the different diameters surfaces, forming the step from one diameter to the other called the shoulder. There are four kinds of shoulders will come: square shoulders, beveled shoulders, radius shoulders, undercut shoulders. Here you can see the different shoulders. It is a square shoulder, beveled shoulder, then work radius is provided here by using the radius tool, and here you can see undercut type of what shoulder. So these are the different types of turning. One is a turning operation, in that you are getting shoulder turning. Next will come pressing operation. Pressing is the operation of machining at the end of the workpiece to produce a flat surface square with axis by holding it in a chuck or a plate. This operation is used to cut the work to a required length, feeding the work tool against the workpiece. Here you can see pressing operation. Whenever you take any job, you need to get, because while always the workpiece is very lengthy workpiece, raw material, so you are cutting the job at a required size. You are making into small pieces like 100 mm. Okay, after cutting, these both the ends are not accurately flat. To make this accurately flat, and as well as if 100 mm 105 100 length 100 mm length is required, you are cutting at the 102 mm or 100 mm 3 mm, means 3 mm extra you are keeping to make these both the ends flat, to make these both the ends exactly flat, right? To make this exactly both the ends flat, and 102 will be made 100 mm by this pressing operation, by reducing at the by machining at the ends. Here you can see the diagram of the pressing operation, whereas here this workpiece is turned at the some angle they are keeping. This is 56 degree they are keeping along the workpiece center, and pressing operation is performed up to half, because job is rotating 360 degree, only half still at one center we are moving the tool. Next comes taper and taper turning. Taper turning is the operation of uniform increase or decrease in the diameter of the workpiece measured along its length. Because in so many cases we need some taper. So during that time we need to machine the job at some taper. What is taper? Here you can take your workpiece is like this, and you need paper like this, right? This material is to be removed out. Then the workpiece is like this. This is called taper. One end it is you want 50 mm, and other end you want it 25 mm or 30 mm. This is called taper job. So that is what we are calling it as uniform increase or decrease in diameter along the length. So taper turning is produces conical surface by gradual reduction in diameter from the cylindrical job. Here you can see the taper job is shown here. This is the taper turning the other end. Along when they connect it, they got an angle here, alpha. Right here you can see D means large diameter, small d means small diameter, L is the length of the job, right? Alpha is the half angle. These are the elements of the taper. Taper may be produced by feeding the tool at an angle to the axis of rotation of the workpiece in a lathe. A taper may be turned by any one of the method by using the 5 methods are there. These are very important. Any one method they will ask in the exam. Taper turning by using broad nose form tool, taper turning by tailstock set over method, taper turning by swiveling the compound rest, taper turning by using taper turning attachments, by combination of longitudinal and cross feed in a special lathe. Here most of the in any university syllabuses they will use commonly taper turning by compound rest method. Questions will be asked repeatedly, and in the workshops also they will be used the same method for the turning purpose. Taper turning by tailstock set over method. So once again you will see first types. By using the broad nose form tool, tailstock set over method, taper turning by compound rest method, taper turning by using turning attachments, by combination of longitudinal and cross feed in a special lathe. Now we will see first one, taper turning by tailstock set over method. Here you can see taper turning by tailstock set over method. In this method, axis of rotation of the workpiece is shifted at an angle is equal to half angle of the taper to the lathe axis and feeding the tool parallel to the lathe axis as shown in figure here. So here what happens, the tailstock is made set at some angle is called set over. It is called set over, and here you can see arrangement of the job, how they are turning. Okay, by setting over the tailstock, the taper turning method itself is setting over the tailstock. Taper turning by tailstock set over method means axis of rotation of the workpiece is shifted at an angle. Tailstock need to be set at some height and job is held at some angle, and taper turning is made. Here you can see for exam point of view to practice this diagram. Okay, here the calculation they are given here for the set over. Set over is equal to L tan alpha. L is equal to L into D minus D divided by 2 L in mm, and finally you are getting the set over. The formula is set over is equal to L into K by 2. So K is known as conicity or amount of taper. Here the taper turning is done for entire length, then small l is equal to capital L. So capital L into D minus D divided by 2L is the formula. Here one example they are given. The length of the workpiece is 200 mm and the amount of taper is 1 is to 50. Find the set over required. What is 1 is to 50? See, if you consider a job for 50 mm length, 1 mm will be the taper. If it is 100 mm, what is the taper? Then it becomes a 2 mm. If 1 mm means what? If it is 50 mm here, okay, so you need to calculate it by putting in this formula. So but main importantly, remember, for 50 mm 1 mm taper, for 100 mm 2 mm taper, right? L is 200 mm, K is equal to 1 by 50, that is the taper ratio. Put in the formula, set over is equal to L into K by 2. 200 is the length and K is 1 by 50, that is the taper ratio. So we are getting 4 by 2, that is 2 mm is the set over. You need to set the tail stop. Same problems are given here. Find the angle at which the compound rest will be swayed when cutting a taper on a piece of work having outside diameter 60 mm, smaller diameter on the tapered length is 20 mm and tapered length is 80 mm. So this is compound rest, taper turning by the compound rest method. Compound rest method will be discussed here. Compound rest method is not taken. I think that notes have not taken. So I hope you understood the different methods. Whatever I discussed now, we'll overlook what all the things we discussed till now. We have discussed mainly the what is catch plates and different types of catch plates or the driving plates. So catch plates are the are used to drive the workpiece to docks when it is held between the two centers. I also shown the video on this. There are single pin catch plates, double pin catch plates, double slotted catch plates, and then we discussed about the rest. What is rest? Rest is a mechanical device which supports a long slender workpiece to be turned between the centers or by a clutch. Here to prevent the bending, the very heavy lengthy job, and to prevent vibrations we are using a steady rest. Yes, you take example of JCB cylinder and connecting wrong rod arrangement or making of the power packs, we required very lengthy connecting rod. So that time we need to use this steady rest or follower rest. In most of the all hydraulic industries they are using this, even in for casting the automobile parts, for machining the automobile parts. Steady rest, you can see the diagram. Follower rest, these differences are discussed. The lathe operations, turning operations, in that you have two types, rough turning and finish turning. Then shoulder turning, you have four types: square shoulder, beveled shoulder, radius shoulders and undercut shoulders. Then we'll discuss about pacing operation to make the both the ends flat and reduce the length. Taper turning we have discussed only two methods: taper turning by tilt set over method. In the next class I'll discuss about some other methods of the taper turning. Okay, so if any difficulties are there, you can put in the comment of this YouTube channel, as well as you like my channel, subscribe and share these videos to your friends, other college friends. And if any suggestions are there, you can put in my WhatsApp number. So thank you very much for your patient listening. After completion of this class, I'll send the notes to your WhatsApp group. So write it down in the notes book by making the point wise notes which will help you for your exam. Mainly in this subject, you practice the diagrams and understand the concept in your own way. Even though if you write in your own way with proper points, you will get the marks. Okay, with this we'll end the today's session.